Hello everybody. Today what we're going to be doing is looking at our last video of the year. And so let's go ahead and take it out. We're going to take notes on this really quickly and yeah, let's get going. So the first thing is our warm-up. It says what we want to do is figure out the solution to these three problems, and we're going to look at a brand new method. I've actually never seen this. And it says I want us to make two equations, the one on the left and the one on the right. So essentially what we're going to do is plug these equations into Desmos, and we'll have one looking like y equals 4x minus 2. And we want to put a second equation as y equals 10. And we want to see where do these two lines intersect. So instead of, moving 2 onto the right side and dividing by 4, what we're going to do is basically set up two equations for each ones. So once again, on this second equation down here, it looked like y equals 25. And then the next equation would be y equals x minus 3 squared. And then finally, my last one over here on number 3, it would look like this. I would have y equals 343 and y equals parentheses x plus 5 cubed. All right, so I already had these plugged into Desmos, so we're going to just look at these one at a time. These are my first two equations. I'm going to go ahead and make the 4x minus 2 be visible, and y equals 10. So if we look at this now, this point right here is my solution. So you see how it's 3 comma 10? So the solution here is 3. It's just the x value. So if we're going to just go ahead and do this for this first one right here, but if you went ahead and solved this just normal over here, you'd get 4x is equal to 12. And when you divide both sides by 4, you'd get x equals 3. So you can just go ahead then and see that on your graph. That's just where those two values intersect right there on the 3. Okay? So the next one now, I'm going to go ahead and make these disappear. I'm going to have y equals 25 in green, and then y equals x minus 3 to the second power. And when I see these two, I'm going to have a solution here. It's just the x value of negative 2, and it actually has a second value of positive 8. So negative 2 and positive 8. So like I said, brand new method of solving these. And so if I were just to do this, we have negative 2 and negative 8. Positive 8 are my x values. And for that, to figure this out, you just take the square root of both sides. Remember, the square root of 25 is positive 5 equals x minus 3, as well as negative 5 equals x minus 3. So when you solve these, you'd get your 8 equals x, like we just did over here. And when I add 3 on over here, you'd get your x equals negative 2. So that's how you get that value over here. So that's just another way of showing you how to do it. Our last and final way, or equation I should say, is let's go and look at this one. If I were to make these invisible, we're just going to go and plug these in. So I got y equals 343. So let's zoom out so we can actually see that. We got this one right here. Let's plug in x equals, let's see if this changes anything. I don't think it will. Y equals x plus 5 to the third power. And we zoom on in. We can see where these intersect, which would be right here, which would be 2. So if I were to set those equal to each other, I'd get the answer of 2. Okay? All right, so that's just a fun little way of figuring out another solution, a way I've never seen before until this. But now what we're going to do is focusing on radicals, okay? Square roots, cubed roots, so on and so forth. So let's look at a few rules here. It says, now that Tia and Tahani know what a to the m over n equals a to the nth to the m power. I should restate that. A to the nth root to the m power. They wonder which radical form or exponent form is best to use for working with numerical and algebraic expressions. Tia says she prefers radicals since she understands the following properties for radicals. There are not too many properties to remember. So here's all the radical properties. So if we looked at this, guys, anytime you have a root of the number to the same power, so it's just going to equal the number inside. So the square root of 4 to the second power, well, those cancel to give me just 4. If you have 5 to the cubed root to the third power, those just cancel, and you're just left with 5, okay? This next one, it says, if I'm taking the nth root of a times b, that's the same thing as a to the nth times a to the nth root times b to the nth root. So for instance, if you're taking the square root of 4 times 5, this is equivalent to the square root of 4 times the square root of 5. You can separate those with a multiplication. Similar if we have a fraction, if you're taking the square root of the numerator, of the whole thing of such as like 4 over 9, that's just equivalent to the square root of 4 over the square root of 9. And as we know, it's just 2 over 3, okay? So some other rules. Anytime we are multiplying similar bases, what we're going to do is add those exponents. So if I have like 4 to the second times 4 to the third, this would just equal 4 to the fifth power. We also know that we can distribute these. So if you have ab to the nth power, we can just distribute that. So it would look something like this. Let's see, 2 times x to the third. This would be distributed to the 2 as well as to the x. So this would be 2 to the third times x to the third. Now when we're dividing, so if I have x to the 7th over x to the third, all I would do is subtract those. Oops. To give me x to the 4th. And finally, guys, anything to the 0 power is just 1. So let's go ahead now and look at these ones. Anytime I have a power to power, I'm going to multiply those. So x to the third times x to the 5th. It's just going to give me x to the 15th. Anytime you have a power on the outside, you just distribute it to the numerator and the denominator. So this would be 2 to the third over 5 to the third. And then anytime you have a negative exponent, whether it's on the numerator or the denominator, you just move it in the opposite spot. So if you have a negative exponent on the numerator, you're going to move that to the denominator. If you have a negative exponent on the denominator, you would move it to the numerator. And only the part that has the negative exponent. Okay. Finally, one thing that we looked at, that we explored this module, is how to write these as a fraction to square root and square root to fraction, or I should say a root, not just a square root. So remember, guys, every time you have a fraction, so I'm going to have a base a, and it's always the power over the root, okay? So if you have the square root of 6, well, it's 6 to the first power, and this is going to be square root, so put 2. This would be 6 to the 1/2. If you have something like 8, 8 is equivalent to 2 to the third power. So you would have 2 to the power of 3, because this is your power, and root 2, so on and so forth, okay? Other ways to look at this one. So we've been looking at stuff that looks like this, like 2 to the third power, square root. This is also, you can also have it the square root of 2 to the third power, okay? Either way, 100% works. That's what's showing all three of these equal to each other. So this would equal to this, which would equal to this as well, okay? So, using their properties, preferred notation, Tia might simplify the cubed root of x to the 8th as following. She says, okay, well, I know it's basically, you have 8 of them, 1, 2, 3, 4, 5, 6, 7, 8. And she's making like little groups of 3. So like x times x times x is x to the third, x times x times x is x to the third, and x times x is x to the second. And she knows that these would cross off, right? Because anything to the third power and the third root, they're just, inverses of each other. They simplify, they go away. So you just have an x and an x left over from these two values. But you still have that x to the cubed root, you still have the cubed root of x to the second power. So x times x is x squared, and times cubed root of x squared, okay? Tony points out that Tia also used some exponent rules in her work. She used a bunch. On the other hand, Tiana might simplify the cubed root of x to the 8th the following. She says, okay, I know that this is the root and this is the power, so I can write it to x to the 8 over the third. Now, if you turn this into a whole number, we know that this is basically x to the 2 and 2/3. And they just wrote it as 2 plus 2/3. Just because in exponents, when it's multiplication, you can then separate it into two separate bases with multiplication. So it's saying I have x to the second power times x to the 2/3, and I know that this is the power, and I know that this is the root. So x squared is all good, but then times x to the second power cubed root 3. Remember, the other way to write that is the cubed root of x to the second power. These are both equivalent, okay? But we're going to leave it in this notation right here. So that's another way how to simplify it. So what we're going to do is we are going to go ahead and simplify these, both Tia's method and Tiana's method, okay? So first things that we're going to do is we're going to go ahead and look at it like this. So you might want to make a factor tree on some of these, so you basically know that 3 times 3 times 3 is what 27 is equivalent to. So I always just kind of like circled my pairs, but another way to think about this then is if we looked at Tia's method, she's saying, oh, okay, I have the square root of 3 to the second power times the square root of 3. Okay, so you're basically just kind of like throwing in little groups there. And what happens is the second power and the square root cancel, so you're left with 3 times the cubed root of 3. And then you're done. Okay? Tiana's method is basically you got 3 to the third power, but we're taking the square root of that. So that's equivalent of 3 to the third power over 2, which she kind of broke down originally as 3 to the first times 3 and 1/2, which is just equal to 3 square root 3. Okay? Just so you guys know, I'm going to use several different methods when I solve these. What I personally saw is I know that 20 square root of 27 is the same thing as 3 to the second power times 3. And I know 3 to the square root of 3 is 3 times root 3. So I kind of go jump and forth. It just depends on how you factor it, okay? Now, some of those are easier to factor than others. We have 1080. So I already made a little factor tree. So if we went ahead and did this, I'll do it in Tia's section. So I have the square root of 1080. And what we got is 540 and 2. And we got 270 and 2. And then I have 27 and 10. And then I just have 3, 3, 3, and then 2 and 5. So what I'm essentially looking at here now is 3 to the third power. So I got 3 of these, 1, 2, 3, times 2 to the third power, times 5. Okay? And this is all under square roots. And so basically, Tia's method, which really separates it out, which I'm not the biggest fan of, it would basically be 3 to the second power, square root of that, times 3 to the first power, square root that, times 2 to the second power, square root that, times 2 to the first power, square root that, times 2 to the fifth power. So I know that this cancels out to give me 3, this cancels out to give me 2, and then I'm left with the inside the radical of 3 times 2 times 5, multiply outside with outside and inside with inside to give me 6 radical 30. Okay? Now if I looked at my factors again right here, I would have 3 to the third times 2 to the third times 5 to the first. I'm just dividing these by 2. So what this would then give me is, I have 3 cubed root 3 times 2 cubed root 2 times the cubed root of 5. Multiply outside with outside to get 6. Multiply inside with inside to get the square root of 30. Okay? All right, so let's go ahead and look at 32. So 32 is, let's see, cubed root. 2 to the fifth power. So this would just give me the square root of 2 to the second times the 2 square root 2 to the second times the square root of 2 to the first. This right here then would give me then 2 times square root of 2, which would give me 4 root 2. On the other hand, Tiana's method would give me 2 to the fifth power over 2. This would give me 2 to the second times 2 to the 1/2. This would give me 4 times square root 2. All right, so here, over here, I have 20. 20 is just 4 times 5, so this would give me 2 to the second times 5 to the first times x to the second times x to the second times x to the second times x. So if you're wondering why did I write it out, remember guys, we're going to put these in the little square roots. And we're trying to make the power match the root, so then I can just simplify that to 2. I still got my square root 5, that doesn't cancel. But these 3 x's cancel. 1, 2, 3. And I have another square root of x right here. So then this would give me 2x to the third power times the square root of 5x. Okay? All right, now if we go and look at the same idea over here, we're going to have 2 to the second power over 2 times 5 to the first power over 2 times x to the seventh power over 2. Now, what these would simplify, this would just give me 2. And every time you're left with like a fraction, like 1 over the fraction, you're going to have that number on the inside. So it's 5 to the first. And then over here, x to the 7 over 2, that's 3.5. So give me x to the third, and that 1/2 of that 0.5 would be represented inside the square root. And if you notice, I get the same answer. Now, me personally, I always find Tihana's method a little easier. So that's the one I usually use. Okay, so we're going to look at these together. Now, it's important, guys, I already made factor trees. So if you didn't do this already, you could see that maybe that this is, 9 times 6. And then I know that this is 3 times 3 times 3 times 2. Now, usually what I would do is I just circle the pair to get 3 root 6. But using these methods, looking at Tiana's method, I noticed that this is 3 to the third power times 2 to the first power. And what we're going to do is whatever the root is, that's what my denominator is. So I know that this is 3 root 3. And I know that the 2 would stay on the inside, so because there's nothing I can pull out, so I leave the 2 on the inside. Then you multiply outside with outside and inside with inside. So either way, it's all good. Okay? All right, 252. So right here, I have a factor tree of 2 and 126, 2 and 63. Let's see, that would be 9 and 7, which breaks down to 3 and 3. So I have 2 to the second power times 3 to the second power times 7 times x to the fifth power. And since I'm looking for the square root, I just divide these by 2. And let's go and take these one at a time. This reduces to just 2. This reduces to just times 3. This has a 1/2. So there are no whole numbers, so that would stay inside the radical. This would have a whole number of x to the second power with a remainder 1 inside the square root. So we're going to multiply the outside to give me 6x squared times the square root of 7x. Okay. So let's go and do letter C. So 432, and this is still to the second power. So let's go ahead and look at this. We got 2 times 216, 2 times 108, 2 and 54. And we already know that really quickly, we already took care of the square root of 54, and we knew that that broke down to 3 to the third times 2. Okay, we did that on example A. Okay, that's how I was able to get that. But if not, you can continue to break that down to 9 and 6, so on and so forth. So anyways, this just gives me now I have 1, 2, 3, 4. So this is 2 to the fourth power times 3 to the third times x to the eighth times y to the ninth. All right, so now remember Tiana's method, what she wanted us to do is she said, let's go ahead and I look at my root. And the root is just a square root, so I divide all these by 2. So this would give me 2 to the second times 3 to the first times x to the fourth and y to the fourth. Remember, I'm just looking at the whole numbers. So this had no remainders left over. This had 1 remainder left over, so I put the 3 on the inside. This x had no remainders, but this y did. Let's go and multiply the outside. 2 times 2 is 4 times 3 is 12. x to the fourth, y to the fourth, times 3 times square root of 3y. All right, just a handful more. So let's go ahead and look at letter D. This would go ahead and break it down to 150 would be 10 and 15, 2 and 5, 5 and 3. And so then I have my factors of just 2 to the first times 3 to the first times 5 to the second, x to the 7th, y to the 12th. And what we're going to do is just divide all these by 2. So any leftover remainders, non-whole numbers, fraction, exponents will go on the inside. So 2 to the 1/2, no whole number, so I just put the 2 right here. Times 3 to the 1/2, I just put 3 right here. And 5 to the second over 2 is just 5. And then x to the 7th, it would be x to the 3rd power would be my whole number. So let's go ahead and write x to the 3rd with a leftover and the inside x. And y to the 12th divided by 2 is just y to the 6th. This would give me 5x to the 3rd, y to the 6th, times the square root of 6x. All right, now guys, brand new thing that we haven't seen before. We've seen in these handful of examples. What we're going to be doing now is looking at y to the 3rd power, excuse me, 3rd root. So when I look at 108, guys, this would give me 2 and 54, 2 and 27, and then 3 to the 3rd power. 3 times 3 times 3 is 27, okay? So now I'm going to have 2 to the 2nd power times 3 to the 3rd power times x to the 4th power times y to the 9th power. And what I'm going to do is divide all of these by 3. This would then give me, I have a cubed root, so I would have 2 to the 2nd power on the inside. I would have 3 on the outside, because 3 divided by 3 is just 1. I would have x to the 1st power with another x left over here, because it's 1 and 1/3, so I have my 1 right here, and the 1/3 is right here. And then I have y to the 3rd. Now multiply outside with outside. I'm going to take the cubed root, and then inside with inside. 2 times 2 is 4x. Okay. All right, let's go ahead and keep going. So for letter F, I'm going to go ahead and just crank through these really quickly, guys. This would be 2 to the 1, 2, 3, 4, 5, 6 power times 7, okay? So let's go ahead and write this out now. I have 2 to the 6th times 7 times x to the 8th times y to the 12th. Now this one's a little different because when we notice, remember we're going to divide all these by 3. And the difference here, so far we got 2 to the 2nd, no difference there. 7 to the 1/3, that will be left in here. Now this is where it's just a tad different because this would be 2 and 2/3, or x to the 2 and 2/3. So the whole number right here would be x to the 2nd. The x to the 2/3 would then go in here. And with the numerator, remember that's the power, and this is the root, okay? So nothing can get pulled out there. You need 3 to pull it out, and you only had 2. So that's how that stays. And then I got y to the 4th power. Then I just multiply outside with outside to get 4x squared y to the 1st times the cubed root of 7x squared, okay? All right, last, we got 3 more, okay? So if you were to look at this, this would be 5 times 3 times 1, 2, 3, 4, 2 to the 4th power. So what we are doing, guys, is we are looking for the 4th root. So you're looking for 4 of a kind now. So you got these exponents of 1 on the 5 and the 3, and what we're going to do is just divide these by 4. And so we're going to have a 2 on the outside, but we're going to have the 5 and the times the 3 on the inside, which would give me 2 4th root 15. All right, 2,592. This would look like 2 times 2 times 2 times 2. Let's see, 1, 2, 3, 4, 5. and then 3 times 3 times 3 times 3. Okay, times y to the 10th times y to the 14th. So this right here would give me 2 to the 5th times 3 to the 4th times y to the 10th times y to the 14th. And so what we're going to do is we are going to go ahead and divide all of these by 4 because we're looking for the 4th root now. So I have the 4th root. And so 5 divided by 4, this would be 2 and 1 and 1/4. And remember the exponent rules is 2 to the first times 2 to the 1/4. So that 2 would come on the outside. So I have that 2. And then I have 1 in the 2 to the first power on the inside. Okay. Next, I would have 3. And then over here, you would have y to the 2nd. And you have basically a leftover. So what I'm doing here, guys, is y is equal to 2 and 2/4. This y to the 2nd goes on the outside. This would be the power on the inside, so it would be y to the 2nd and to the 4th root. And did I mess up on my variables? I did somewhere. So that should have been x on all those. I put y twice. Oops. Let me just fix all that. So we got x, x, and x. All right, and finally, guys, over here, y to the 14th over 4, that would reduce to y to the 3rd, y to the 2nd. Okay. Yeah. Okay. Just double checking in my head. Last one. Oh, nope. Last one. So right here, guys, I got 10 and 16. I got 4 and 4. I got 2, 2, 2, 2, and a 2 and a 5. So this is 2 to the 5th times 5 times x to the 9, y to the 20th. And what we're going to do is just divide all of these by 5. So I'm going to have a 5th root. And then I'm just going to have 2 on the outside. I have 5 on the inside. So I took care of those numbers. And then I'm going to have x to the 9 over 5. Well, okay, I can make one whole number here. But then I'm going to have a leftover 4 here. And then I'm going to have y to the 5th power on the outside. And there, guys, is the last lesson to Math Integrated 1. I am so sad this is how we finish this year through video. I miss all of you. Carmel Valley kiddos, thank you for letting me teach you as well. Hopefully you made it to the end of this lesson. And yeah, I will see the rest of you guys a little later. And have a great day.